On March the 23rd, 2012, NASA Mission Control told the crew of the International Space Station in space on the radio that a lot of micrometeorites are going to collide with the ISS in 6 minutes. This radio message made a ruckus in the entire ISS. The astronauts had so little time that they couldn't even change the direction of the space station during this time. But the question is, in the part of space where ISS is present, there are countless micrometeorites. So how does the International Space Station, i.e. ISS, survive these meteorites? How is this work done without fuel and without Earth to change the direction of the weighty ISS of 380 vehicles? How was a football field-sized ISS taken from Earth to space? And when the ISS is on the other side of the Earth, how is it contacted? Welcome to Recap English's videos once again. Viewers, 150 billion, or 12 billion, 375 million rupees. ISS is a home for humans in space, whose example is nowhere to be found in history. There are hundreds of high-tech parts to make it. It has 16 pressurized modules, in which different modules for living and sleeping, for an observation deck, and for 6 science labs. Different modules are included, which are all connected to each other through an airtight tunnel. In addition to these, many spots in the ISS are still empty. In some extra capsules, the lifeboats of the ISS are parked in some of them forever, so that if there is any problem in the event of an emergency, these lifeboats can safely take the astronauts to Earth. International Space Station is the largest space station ever built. An ISS as big as a football field may be 400 kilometers away from the ground, but it can still be seen from the ground with the help of binoculars. Or if you want to estimate its size from a real-life object, then assume that Burj Khalifa's bottom or its base is larger than the International Space Station. The total weight of the ISS is 4,600,000 kilograms. This is the same weight as that of 380 cars or 25 passenger buses. But the question is, how did such a heavy and large ISS go into space? How did it go into space? The ISS began with only 2 modules, and they were connected to each other in space. One module was made by America, the other by Russia. In 1992, after the collapse of the Soviet Union, America and Russia collaborated, and the 2 superpowers decided to build an international space station in space. First, Russia sent a module named Zarya into space, and then America sent its own Unity after it. Flying at a speed of 27,000 kilometers per hour, Unity followed Zarya. On November 20th, 1998, at 6:40 in the morning, these 2 modules were connected to each other 400 kilometers above the ground, and this is how the International Space Station was. In the last 26 years, engineers from all over the world have worked together to build their own modules and sent them into space through rockets and connected them to the ISS. Today, in addition to the US and Russia, European and Japanese modules are also connected to the International Space Station. From the year 2000 to date, there has not been a single day in the ISS in 24 years in which it has been empty. Every time there are astronauts from some country present in it. In the ISS, all those facilities are present to meet the needs of the astronauts, which should be in any superstructure, in which oxygen is the most important. A human being can live for 3 weeks without food, 3 days without water, and 3 minutes without oxygen. 400 kilometers above the ground, where there is no atmosphere or oxygen to breathe, the biggest challenge for the ISS is to provide astronauts with fresh oxygen. An average person needs 15,000 liters, or 22 kilograms of oxygen. For 9 astronauts living in the ISS, it is a big challenge to provide 200 kilograms of oxygen per day. Here, oxygen supply for astronauts for many days is present in tanks, so that if the system fails, the oxygen supply from Earth to the rockets should be enough for the astronauts to survive. Today, technology has become so advanced that oxygen supply can be delivered from Earth to the ISS in just 6 hours. Oxygen supply can be delivered. but only if the rocket launch is successful in that condition. This method is good, but it is very costly, because a cargo rocket costs $200 million ISS, 165 crore rupees. Food and other supplies are sent once in many months, but it is very difficult to use rockets again and again to meet the oxygen demands of 200 kilograms per day. It is very difficult to use rockets again and again. This is why the ISS produces its own oxygen without the Earth's dependency. It has a small machine that produces oxygen by using water, nothing else. When electricity is passed through water, it breaks into two parts, hydrogen and oxygen. Hydrogen gas bubbles accumulate on the positive electrode, and oxygen gas bubbles accumulate on the negative electrode. Now, if this experiment is done on Earth, then these bubbles automatically separate from the water. But there is no gravity in space. The weight of the water is the same as that of the gas, i.e., almost zero. So now, to separate the oxygen gas from the water, this machine is rotated, which creates a centrifugal force, which acts as an artificial gravity. The centrifugal force acts as an artificial gravity. Because of the rotation, the water moves to the sides, and oxygen gas is left in the middle, which is collected by the machine itself and put in the container. Now here, you must be thinking that if oxygen is made from water in ISS, then where does the water come from in space? Here too, brilliant engineering shows its magic. In this process, the hydrogen gas is reacted with the carbon dioxide gas that comes out of the astronaut's breath, and water is made again. And finally, methane gas is left, which is wasted in space. Making oxygen for the International Space Station is a big challenge in itself, but the bigger challenge is to keep this oxygen safe. In 1 second, the space station will burst into pieces. The example of the recently destroyed Titan submersible is in front of all of us. There is a lot of pressure in the sea, while there was controlled pressure in the Titan. As soon as its solution leaked, the pressure in the sea compressed it badly in less than a second. But in space, it's the exact opposite. The outer pressure here is zero, while the pressure inside the ISS is maintained. Just like the Titan, if there is even a small crack in it, it will decompress and explode. The height at which the ISS orbits the Earth, there is a lot of space debris here, which is rotating in space at a very high speed. These include satellite parts and hundreds of small and large meteorites. So the question is, how does the ISS protect itself from these meteorites? The International Space Station is orbiting the Earth at a speed of 27,000 kilometers per hour. This is such a fast speed that if it flies at this speed, it can cross the Pacific Ocean in just 25 minutes. The same Pacific Ocean, which takes commercial planes 13 hours to cross. At this speed, if it collides with a meteorite, it will be like a car crashing into a tree at a speed of 80. On March the 23rd, 2012, NASA Mission Control radioed the ISS crew that some space debris is heading straight for the ISS. No one knew how big this debris was. NASA Jet Propulsion Laboratory, California Institute of Technology 6 minutes ago. The entire crew immediately boarded the lifeboats, but fortunately, the space debris passed right by the ISS without touching it. But the ISS meteorites every time. In order to protect itself from small particles, the solution of the ISS was made from bulletproof material. Just as there are different layers in bulletproof vest, the solution of the ISS was also made by mixing different layers. The outermost layer is made of aluminum, then a layer of woven material, and then a layer of aluminum again. A single metal is not as strong as cutting the same metal and spreading it in 2 or more layers. Every passing moment, micrometeorites like sand grains are attacking the ISS, but these are its bulletproof layers that have protected the ISS for the past 26 years. But what happens if a big meteorite comes in ISS? It's not as big as the size of the vehicle, but it's only 1 inch bigger. In this case, the bulletproofing of the ISS will not work at all if it collides at such a speed. The mission control crew on the ground already has an idea of the location and position of the upcoming meteorites. If this seems like a loss, then in this case, the entire ISS has to be removed from the road. It can be changed by using the small thrusters in the ISS, and these thrusters run on rocket fuel, and this fuel is very little with the ISS, only for emergency purposes. In order to end the dependency on the Earth of the ISS, a mechanism has been installed in it, which without using rocket fuel, easily changes the direction of the 4 60,000 kilogram weight ISS. There are small boxes in it, control, moment gyroscopes, or CMGs. But how do they change the direction of a football field? These boxes contain flywheels, which spin at a speed of 6,600 rounds per minute. Flywheels are like heavy round wheels, just like train wheels. When they are spinned at high speed, angular momentum is generated. This momentum is transferred to the entire body of the ISS, and thus the entire ISS starts to move in one direction. If the flywheel is very fast, direction, or this direction, other opposite direction, I direction, may spin ca. In flywheel, electricity panels generate orbit, so sunrise. And even when the sun is there, it shifts its position so fast that if the solar panels are fixed, they will not get direct sunlight, and they will not produce electricity properly. That is why these solar panels always keep their direction towards the sun. Solar panels, kilowatt electricity, air conditioners. Zrenia International Station, mission control communication radio signals. These signals can't cross Earth, and often the ISS is at the other end of Earth. To solve this problem, the first aircraft was flown, which would pick up the ISS radio signals and send them to Houston for mission control. This method was costly and also very unreliable. Often, the contact with the ISS would be disconnected for up to an hour until it returned to Earth's orbit and reached the mission control range. But that doesn't happen anymore. With the advancement of technology and the help of high Earth orbiting satellites, the problem of communication has now been eradicated forever. Whenever the ISS has to communicate with mission control, the first signal is received by the satellite. Then that same signal is sent to the satellite's network, and then whatever satellite is in the range, it relays that signal to Houston Mission Control. In this way, with just a few seconds of delay, the astronauts in the ISS can easily connect with their families. Scientists around the world have been trying to make the ISS self-sufficient for the past 26 years. A space station that needs as little as possible of Earth. Many inventions have been made for this purpose, but there are still many requirements that need Earth's help to meet, such as food, chemicals, spare parts, and crew shifting to filter water. Because an astronaut can't stay in space for more than 8 months, there are many labs at the International Space Station to perform various types of experiments, most of which are done on the human body. The only purpose is that when humans go to Mars or deep space, they may have to face various difficulties. The ISS is only 6 hours away from Earth, but when humans go to Mars, there will be no Earth support, nor will the way back be so easy. I hope you will like and share this video of Recap Englishes. Very much for your loving comments. See you in the next great video.